Good morning, Year 10. Today I'm going to do a reacting mass calculation. I've got my two helpers. Introduce yourself, please.
Hi, I'm Emmett.
Ava, introduce yourself. You don't have to look, just speak for me,
Hi.
please. Say hi,
I'm Ava.
Okay, so let's...
She's the shy one.
She is the shy one. Let's go through this calculation then. Reacting masses, come on down here. Oh, wait there, can you show the Year 10s my t-shirt? Just to get them in a good mood.
He's the daddy
Okay,
now.
can you see it?
Yeah.
Okay.
It's not Christmas
This
yet,
is my new uniform of work today.
Not
So,
Christmas though.
You on there then, babe?
Yeah, who
Right,
cares?
reacting masses. The question
Still
here,
making toys.
this is called limestone. And you do a topic on this and I'll get some stuff sent to you. And this is called, I guess we call it lime. Right? But really it's calcium oxide or calcium carbonate. So I'll just do that. So the question says, how many tons of limestone is needed to make 112 tons of lime? Okay, so we want to know how much of this we need. Now I've picked this question because I think it simplifies things a bit more. It's a balanced equation. What's that, sorry, Em?
Is it 15?
Is it 15? Not quite. It's a balanced equation. Calcium carbonate goes to calcium oxide plus carbon dioxide. There's no big numbers, so in other words, it's a 1 to 1 to 1 reaction. So if we had 1 mole of that, it means we have 1 mole of that, 1 mole of that. If we had 2 moles of this, it means we have 2 moles of this, 2 moles of this. And we're going to do the reacting masses using the moles method. So, my triangle in the corner. Number of moles, mass, AR or MR. And as you can see by the PowerPoint, I've given you kind of very specific instructions to this. Not that PowerPoint, babe. This, the PowerPoint I put on a Google Classroom. So, first of all then, let's work out, if we've got 112 tons of lime, let's work out how many moles of lime we've got. Now, we can do this two ways. We can convert this into grams, but because the answer is going to be in tons, I'm just going to keep this as tons. So I'm going to assume moles, instead of moles per gram, it's going to be moles per ton, but it's going to be the same, so they'll just cancel out. So, number of moles equals mass, which is 112, over our MR of our molecule, CaO. Now, the mass number of calcium is 40, and the mass number of oxygen is 16. So in other words, 112, calculate time, 112 divided by 56, which gives me 2 moles. Now, if I've got 2 moles of calcium oxide, how many moles of calcium carbonate have I got? Anyone?
7?
No! How many moles of, if I've got 2 moles of calcium oxide, how many moles of calcium carbonate?
2.
Correct. Okay.
Yay!
Ding, ding,
I'm a
ding.
year 10!
So there we go. We therefore have 2
I'm
moles
year 10 because I'm
of calcium carbonate. So this time now we know moles and we know MR. We always know MR because we can work it out. So it's 2 times. So calcium is 40. Carbon is 12. Oxygen is 16.
52.
Which equals, I'll do this separate, so it's 2 times 40, I'll do it on the calculator, just to make sure I don't make a mistake. 52, add 16, add 16, add 16, equals 2 times 100, which equals
200.
200.
And
So in other words, 200 tons, because we stuck with tons either side. Now, if look at this, let's check that this does look right. So what I'm saying here is the question was, how many tons of calcium carbonate do I need to make 112 tons of lime? Well, you can see we've also lost quite a bit of carbon dioxide. In fact, you know, if we started off with 200 tons of this, 112 tons of this, whatever's left over, which would be 88, would be the carbon dioxide, which sounds about right actually. And you can kind of don't just do this without having a bit of a look at the numbers itself.
sorry.
So I hope that this makes sense. I'm going to put some more of these videos on. Keep in touch. Email me if you can think of anything that can help you out.
And don't forget to subscribe and like.
Subscribe and like. Thank you. Bye everyone.
Bye.